In this video, we will be computing some one-sided limits. The first thing to notice is what happens when we just try plugging and chugging. If we let x be 2, what do we get? We notice that we end up with a 0 on the numerator and a 0 on the denominator, and we do not know how to handle this. We'll learn some techniques this semester to help us, but for right now, this is just a big unknown, so we can't proceed with this. Let's use our skills of rewriting absolute value functions as piecewise defined to help us work with this. So we could start simple. We can just say that x minus 2 can be written as a piecewise defined function, where one piece will be x minus 2 and the other piece will be negative x minus 2 quantity. And we can use the positive piece when the x values are going to be positive, when the input is positive. Well, where is that going to happen? That's going to happen when we set x minus 2 equal to 0, and we say that x equals 2 is going to be our split point. So if x is larger than 2, then we can just ignore the absolute value signs. But if x is smaller than 2, we need to multiply by a negative to counteract the negative nature of x minus 2. And pick your favorite place for equality. I'll just throw that on the top. Now that we have a way of thinking about x minus 2 without absolute value symbols, let's see what this does for us when we rewrite our limits. So if we're taking the limit as x is approaching 2 from the left, what do we know about these x values? If x is approaching 2 from the left, we're on the left side of 2, so those values of x have to be smaller than 2, which puts us in the case of knowing that instead of writing absolute value of x minus 2, I can write a negative x minus 2. And this is a good hint as to why I didn't simplify and distribute out. What do we notice now about the x minus 2 terms? As long as x is not exactly equal to 2, we can do the division. And since we're taking a limit, x is near 2, but not exactly 2. And so we can go ahead, not taking the limit yet, we're just doing algebra. We can go ahead and cancel out those x minus 2 terms, and we're left with the negative 1 on top and a 1 on the bottom. Now we can take the limit. What happens to negative 1 as x is approaching 2? Well, it doesn't change. The answer is negative 1. Similarly, approaching x from the right side of 2 allows us to think about only x values that are greater than 2. This tells us we can replace the absolute value of x minus 2 with a positive x minus 2. And again, we can do the cancellation. So again, just algebra, not taking the limit. When we take x minus 2 and divide by x minus 2, we're left with 1. And now we can take the limit. What's the limit of 1 as x is approaching 2? Doesn't matter if it's coming from the left or the right. But in this case, even coming from the right, the answer would be 1. All right, how about this last limit? We call this a two-sided limit. So remember, a limit exists if you can make the function values as close to the limit L as we want by picking values of x close to, in this case, 2. But we see that no matter how close we get to 2, if our values are slightly smaller than 2, the outputs are going to be close to negative 1. And if the inputs are slightly larger than 2, the outputs will be close to positive 1. So we'll never be able to shrink that distance between plus 1 and minus 1. So there is no one single value that this function approaches by making x close to 2, and we conclude that this limit does not exist.